Welcome to 10th session of Unit 2 in Mechanical Measurements. The Unit 2 is about transducers and strain gauges. In that, 10th session is about Rosette gauges and gauge factor. The strain gauges are devices used to measure strain or deformation of an object. In engineering field, we come across many applications where we need stress and strain analysis. So, the strain gauge plays an vital role in the stress and strain analysis. The strain gauges are mainly used. The first one is to measure strain at a point on a loaded member. Second is it acts as a strain sensitive transducer element in the measurement of force, pressure, torque, displacement, etc. The strain gauges are mainly classified into mechanical strain gauge, electrical strain gauge, and optical strain gauge. Most commonly used strain gauge is an electrical resistance strain gauge. The electrical resistance strain gauge works on the principle that when a metallic wire type gauge is strained, there will be change in the length and diameter of the wire. Due to change in the length and diameter of the wire, there will be change in the resistance of the wire. The change in the resistance of the wire will be proportional to the strain produced in the wire. So this change in the resistance can be used using a Wheatstone bridge circuit. In today's session, the topics to be discussed are the first one is introduction to Rosette gauge. Second one is two element Rosette gauge. Third one is three element Rosette gauge. And fourth and the last is gauge factor. Coming to the first topic, that is introduction to Rosette gauge. We know that the strain gauge is used for measuring the strain. The single strain gauge effectively measure the strain in only one direction. If the direction of principal stress is known, the gauges can be oriented and positioned in that direction easily. So let us know what is principal stress. So the principal stresses are the extreme values of normal stresses possible in the material when it is loaded. Maximum normal stresses called major principal stress, and the minimum normal stress is called minor principal stress. But in practical situations, the parts are subjected to stresses multidirectionally. That is more than one direction. And it is very difficult to locate the direction of the stresses. When the direction of stresses are not known, the strain gauges cannot be mounted at a exact direction of the stress. That is, the orientation of the gauges becomes difficult. The solution for this is using of two or more strain gauges to form a unit called rosette. The common meaning of rosette is arranging any part or object more or less resembling a rose flower. The unit of two or more strain gauges to measure the principal strain is called a rosette gauge. Coming to the method of arranging gauges in the rosette. So depending upon the arranging the gauges in the rosette, that is unit, they are classified into first one two element rosette gauge, the second one is three element rosette gauge. Again in three element rosette gauge, there are different patterns in which the gauges are arranged. They are rectangular strain gauge rosette, delta type strain gauge rosette, star type strain gauge rosette. Now let us see the two element rosette gauge. So this is a two element rosette gauge. So as the name suggests, as the name itself suggests, the two element rosette gauge consists of consists of two rosette consists of two gauges. This two element rosette gauge is used for measuring the biaxial stresses whose directions are known. So now let us see what is biaxial stress. Biaxial stress means the stresses that act in planes at right angles. The term biaxial suggests 2D analysis, that is, two-dimensional analysis of the stresses in xy plane. And the stress normal to this plane is assumed to be 0. The biaxial stress is common occurrence in most of the structural part. You can see in the figure the gauge 1 is mounted along x-axis and gauge 2 is mounted along y-axis. So the gauge 1 will measure the strain along the x-axis and gauge 2 will measure the strain along the y-axis. The readings of these two strain gauges is taken to calculate the principal stress. This two element rosette gauge is mainly used for the measurement in members which are subjected to simple tension and compression. So we can see here in this figure the two strain gauges that are arranged one above the other, and they are arranged perpendicular to each other, and there is a shielding, they are shielded with the insulation between them. But when the practical situations, the complex structures, the stresses are not in two direction, they are in multi direction. That is more than two directions. And their directions are not known. In such cases, we cannot measure the principal stresses by using two element Rorschach gauge effectively. So the alternate for this is using of three element Rorschach gauge to calculate the principal stresses. So now let us see the three element Rorschach strain gauge. So in three element Rorschach gauge, again they are classified into rectangular type, delta type, and star type. So first we shall see the rectangular type pattern. Here this is in the figure you can see there. So there are, as the name itself suggests, it consists of three gauges. So these three element Rorschach gauge mainly used for measuring the biaxial stresses in the complex structure whose directions are not known. In the figure you can see there, the gauges are mounted at 0 degree, 45 degree and 90 degree. So the gauges are mounted in the pattern that is at 0 degree, 45 degree and 90 degree. That type of pattern is called rectangular type three element Rorschach gauge. The gauges are, you can see here, the gauges are arranged on one on the top of the other, being insulated between each other. In the figure you can see there, the three gauges are arranged one above the other at the angle 0 degree, 45 degree and 90 degree to the horizontal axis, and all the three gauges are insulated between each other. The stresses measured by the gauge 1 is strain 1, and gauge 2 is strain 2, and gauge 3 is strain 3. So we can see here, by using these three gauges, we get a strain at a desired point in three directions. So by when we get the three strains in three directions, the principal strain can be calculated mathematically. So the formula is given. So that is xy, strain xy is the principal strain at a point. It is given by the formula 2 into strain at gauge B minus strain at gauge A minus strain gauge at C. This is how the principal strain can be calculated using the rectangular type strain gauge where initially the direction of the principal stresses are not known. Next, we shall see the second arrangement of rosette, that is delta rosette strain gauge. The delta rosette strain gauge consists of three gauges which are mounted 60 degree to each other. So we can see in the figure there are three gauges: gauge 1, gauge 2 and gauge 3. The angle between gauge 1 and gauge 2 is 60 degree. Gauge 2 and gauge 3 is 60 degree. Gauge 3 angle between gauge 3 and gauge 1 is 60 degree. Thus it forms an equilateral triangle. So this equilateral triangle shaped rosette is called delta rosette strain gauge. In the figure we can see the maximum stress is acting at a theta which is unknown. The gauges are arranged at 60 degree to each other and the strain is measured by them. Gauge 1 gives the strain 1, gauge 2 gives strain 2 and gauge 3 gives strain 3 in three directions. So these three strains can be used mathematically. By using the formula we can calculate the maximum stress acting on the member which is loaded. That is about the delta rosette strain gauge. Now let us see the third type of rosette arrangement, that is star rosette strain gauge. In the star rosette strain gauge, it consists of three gauges and the gauges are mounted at 0 degree, 120 degree and 240 degree. So in the figure, that is in the second figure, that is a star type, where you can see there the angle between each gauge is 120 degree. The three gauges which are arranged at 120 degree each other gives the strain set strain 1, strain 2 and strain 3 in different directions, that is at 120 degree. These three strains can be used by mathematical formula. We can calculate the value of the maximum stress and thus we can calculate the strain or stress which is acting on a member and whose direction is unknown. So we saw three types in the three element rosette gauge, that is rectangular, delta and star. In that that the rectangular type rosette gauge is more popular, and it is more popular because it is comparatively to other two types, it is more accurate, it is more simple. Next we shall see about gauge factor. The gauge factor can be defined as the ratio of relative change in electrical resistance to the mechanical strain, or it may be also defined as it is a measure of amount of resistance change for a given strain. It is also called as the strain factor. Mathematically, it is expressed as F is equal to PR by R divided by dl by L, where capital F is the gauge factor or strain factor, dr is the change in the resistance, R is the initial resistance. That is, capital R is the resistance of the wire before the load is applied. dr is the final resistance minus initial resistance. That is a change in the resistance after applying the load. L is the original length, that is the length before applying the load. dl, small change in the length, that is dl is final length minus original length, that is a small change in the length when the load is applied on the body or wire. That is, the gauge factor is an index of the strain sensitivity of a gauge. Higher the gauge factor, more will be the sensitivity of strain gauge. Look at the formula. The numerator dl by L is nothing but it is strain. For same strain, suppose if we take two strain gauges, strain gauge 1 and strain gauge 2, the numerical part for two strain gauges, suppose if we take numerator part for strain gauge as 2, and for strain gauge 2 if we take it as 4, then the gauge factor for strain gauge 2, the number 2, which is having numerator as 4, that will have the high gauge factor. That means in the strain gauge 2, which is having high gauge factor, for the same strain as that of strain gauge 1, it indicates that if the numerator is more, the change in the resistance is more for the applied strain. That shows the gauge 2, which is having high gauge factor, will sense or identify the small change in the strain developed. The gauge factor varies for the different substances. The metallic foil gauges have gauge factor as 2, whereas platinum tungsten wire has got gauge factor 4. Platinum iridium has 5 and platinum has 6 as the gauge factor. Whereas the single crystalline silicon has got gauge factor as 200. So that's about gauge factor or strain factor. Coming to the today's summary of this session, the strain gauges are used for measuring the deformation or strain. The single strain gauge cannot measure effectively the stresses in multi directions. It can measure effectively in only one direction, but in practical applications, there are many complex structures which have the stresses acting in multi-directional. So, the solution for this is using two or more gauges in the form of a unit called rosette. So the rosette gauge, again they are depending upon the methods of arrangement, they are classified into two element rosette gauge and three element rosette gauge. Two element rosette gauge best suitable for measurement of biaxial stresses whose directions are known. For the stresses acting in multi-direction, that is more than two directions, the three element rosette gauge is used. Three element rosette gauge are classified depending upon their arrangement of the gauges into rectangular type, delta type and star rosette gauge. In rectangular, the gauges are arranged at the angle 0 degree, 45 degree, 90 degree, and it is the most popular type of the gauge, three element gauge. In delta type, the strain gauges are arranged 60 degree to each other. In star rosette, the gauges are arranged at an angle 120 degree to each other. Next is the gauge factor. Gauge factor can be defined as the ratio of change in electrical resistance to mechanical strain. Gauge factor is unitless. Higher the gauge factor, more will be the sensitivity of strain gauge. So that's all about this session. Thank you for watching the session.